Hi, this session is on our number skills test revision. Now, I won't be going through every single question because a lot of them you can actually check on your calculator, for example, but I'll pick some that you may have found tricky and that we need to cover. So I'll be going with certain questions. So this is question 2 from the test or the practice test. Now with this one, we know we have to think of BIDMAS, or you can call it BODMAS as well. And we can see that B for brackets, we have brackets. There's also multiplication, just here, and that comes before addition and subtraction, okay? So the first thing is, in our brackets, 12 take away 2, I know is 10. And with questions like this, you need to show clear working out and structured working out, which means it should look something like this. You have one equal sign per line, it's only one. And once you've done a step, so I've got my 10, you are going to rewrite everything out. So I have now 20 plus 5, it's still there, times, but instead of my brackets, I now have times 10. And then our next step is we have addition and multiplication. Be very careful, don't go 20 plus 5. We know multiplication is more powerful than addition. So we do that first. And you can put in your own brackets to show that you're doing that first. Okay, so then we have our next step. 5 times 10 is just 50. So now our next line, I'll just write 20 plus 50. And you can see how my working out is nice and clear, and I'm showing everything step by step. And finally, 20 plus 50 is simply 70. So the answer for question 2, you should have circled C, because the answer is 70. Now the next question we'll look at is question 3, and we are on the practice test. You do come across more of these questions where you have factors and multiples and highest common factors. So we'll look at highest common factors at this point. Now, before we even look at this, we know that factors of a number divide evenly into that number. So factors of a number, there's a certain amount, and then it just stops. Whereas multiples, we know multiples can go on forever and ever. It never ends. Now, when you see this, the highest common factor, you have to compare at least 2 numbers because you're going to be comparing their factors. And we have here 12 and 30. So the best thing to do is simply write 12, and we're going to write the factors of 12. Okay, so factors of 12, and to write factors of a number, you know that you start with 1. Every number has a factor of 1 and itself. So on the beginning, I have 1. On the end, I will have 12. Hopefully I left enough space, but we can fix it up later. Okay, so remember, always start with your number 1 and end with the number that's given to you. So for 30, I'll do the same thing. A factor of 30 is 1 and itself. And we know that, for example, 1 times 12 is 12, 1 times 30 is 30. And factors always have a pair or a partner that multiply to give you the number. So now with 12, what numbers can go into 12? Well, we start from 1 and we write these numbers in ascending order from smallest to largest. And simply go up to 12 if you want to, or once you reach halfway, you can pretty much stop, because once you pass halfway, numbers won't really divide into the number. So after 1, I have 2. Can 2 go into 12? Yes, 12 divided by 2, I know is 6. Can 3 go into 12? Yes, 12 divided by 3 is 4, so 3 can go in there. That means 4 can go in there, and I know that 6 can go in there. 5 can't, so 6 comes next, and I stop there. Once I've reached halfway, then you can stop, because you won't be able to divide any more numbers evenly. So they are all the factors of 12. Factors of 30. Can 2 go into 30? 30 divided by 2 is 15. So 15 is its partner. So 2. Can 3 go into 30? Yes. 3 goes 10 times. So 3. Can 4? No. 5? Yes. Goes 6 times. So 6 can go into 30. I probably need to make a bit more room. Can 7 go into 30? No. 8? No. 9? No. 10? Yes, 10 can go into 30. Can 12? No. 13? No. 14? No. I know half of 30 is 15. and then I have 30. I've reached halfway, so I know there'll be no more factors that can divide into 30. And I stop. Okay, so if you get stuck, just remember, start from 1 and then 2 and see if they divide into that number. Now, what we're going to do, so if that was a question, write down the factors of 12. That's all you got to do. Or write down the factors of 30. This is all you have to do. Now, the next thing is, which one is the highest common? So we know common means the same thing or what they have similar. Now, we can see that if there was no highest common factor, if the question said, what are the common factors? We can see both have 1, both have 2, both have 3, both have 6, and that's all. So they actually have 4 common factors, and the highest one is 6. So the highest common factor of 12 and 30, so highest common factor of 12 and 30 is 6, and that would be your final answer. Okay, so remember, write down all the factors of each number and then circle the one that's the highest. So for question 3, it's a multiple choice question. Your answer should have been, what is it? It's B, okay, because B is actually 6. C has 12, but unfortunately 12 is not a factor of 30. Now, I'm going to do number 5. This is an important skill, and we know this symbol here, its actual name for any of these symbols is the radical sign, okay? So you may have learned it in class, the radical sign. Sometimes we see radical signs like this, the cube root of 8, for example, and basically this symbol is asking you a question. Okay, so we'll work on this one here. Now, this symbol here is called the square root, and we're saying the square root of 36, which is what question 5 says. And we know it's called the square root because there's an invisible 2 here, okay? And any little 2 in maths is called a square. If you remember, if you have, for example, 2 centimeter and a little 2 up there, it's saying 2 centimeters squared. And we learn that when we do measurement. Okay, so I'll just write that out. Now, if you go back to your notes, this symbol is simply asking you a question. And the question that it's asking is this: is there a number times itself twice or 2 times? So that's where the 2 comes in. So is there a number multiplied with itself to give you 36, the number in here? It has to be the same number. So can you think of a number times with itself 2 times to give you 36, the same number? Well, we know that 6 times 6 gives us 36. So the answer for this is simply 6, because 6 times 6 is 36. If we try another one, just to practice, before I wrote down the cube root of 8, okay? So with this one, so the answer for question 5 is just 6. So I think it's A on that worksheet. Now, with this extra question here, the cube root of 8, remember, what is the question asking you? This little number 3 is saying, is there a number times itself 3 times to give you 8? And it has to be the same number. For example, I can't go 4 times 2 is 8. I have used 2 different numbers. And the trick is always start with 2, because numbers get large very quickly. If I went, for example, maybe 4 times 4 times 4 will work. Okay, if I picked 4, so a number times itself 3 times, 1, 2, 3, to give you 8, the same number. Is it 4? Let's have a look. 4 times 4 is 16. 16 times 4 is 64. Is that 8? No, it's way too big. So let's try 2. So 2 times 2 times 2, let's see if it gives me 8. 2 times 2 is 4, 4 times 2 is 8. So the number, the answer for this, the cube root, a little 3 in maths is called cube, or you can say the 3 root of 8 is 2, because 2 times itself 3 times actually gives us 8. And that's how the radical sign works, okay? So remember, these little numbers, with the square root, the 2 is always invisible, but other numbers like 3, 4, and 5, they are visible. They are telling you a question. Is there a number times itself this many times to give you the number under that radical sign? Now with question 6, we've got 4 squared, or 4 to the power of 2. And we know this power here is not saying, so it's not saying 4 times 2. A lot of students make that mistake to give us 8. It's simply saying 2 4s, or 4 times 4, which gives us 16. Okay, so just remember, any power you see, get the number and multiply it with itself that many times. So for question 6, you should have had D as your answer, because that is saying 4 times 4. If you had 8, you made a mistake. Now, if I do another question, for example, 2 to the power of 3, this is saying 2 times 2 times 2 3 times to give us 8. 2 times 2 is 4, 4 times 2 is 8. Okay? And just say I wanted to go backwards, that's where the radical sign actually comes in. Because if I put the radical sign over 16, what's a number times itself twice to give us 16? Remember, there's an invisible 2. The square root of 16 is actually equal to 4. We did this before, so that's how we can go backwards. So when you got powers and the radical sign, they're sort of the opposite of each other. So just keep that in mind. With question 10, these symbols here are called inequalities, which means we don't see an equal sign, but our answer can be more than one thing. Now, you have to know how to read these symbols, and just in case you've forgotten, if I have a symbol down here like this, now we read from left to right. So if I'm coming this way, okay, I am hitting, now imagine there's a tiny little gap there. Oops, it came out a bit bigger, but imagine there's a tiny gap there. It's almost invisible, so you can't really see it on these ones, but imagine it's there. It's a smaller gap, whereas this side here, we have the bigger gap. So when you're coming around this way, because I'm hitting the smaller gap, I will say this is the less than or smaller than symbol. So I'll put less, because we usually use less than. So this one's a less than symbol, because we hit the smaller gap first. If I had it facing this way, and we're coming in this way, because we read from left to right, I hit the bigger gap first. There's my smaller gap. Remember, it's just visible. And because I hit my larger gap first, this is the greater than symbol. So greater gap or greater than. And that is the way I used to remember this when I was studying it. And I found it very useful. So to read these questions, let's see. 6 is smaller gap first. 6 is smaller or less than 2. Is that true or false? So for these questions, we have to write true or false. Is 6 smaller than 2? No, so that is false. We know 6 is greater than 2. Let's try this one. 0 is greater than 5. We hit the bigger gap first, so 0 is greater than 5. No, we know that's also false. 5 is greater than 0. And last one, we've got 200. Bigger gap first, so 200 is greater than 2. Well, we know 200 is bigger than 2, so that is true. So C is the only one that was true. Now with question 19, it asks us to find the recurring pattern and write the final answer for the following. So this is the question that I'm doing here, because I'm not going to do D because I'm running out of room. So I'll do the first 3 and you should be able to do D no problem. All right, so with these ones, all we have to do is find the pattern and either use a dot or a dash to show that pattern. And that's it. So we use a dot where we have one number only in our pattern. So 19A, what do you see in our pattern? So what I mean is recurring. So the question actually says, there's a keyword here, find the recurring. Okay, that keyword there, recurring, is simply saying, it sounds like reoccurring. When something reoccurs, it happens again and again. So find the recurring or the repeating pattern and then write your final answer. So we know that these dots here are saying 0.3333 will go on forever and ever and it will never end. But we don't write our answer like this. So the pattern in this, the number repeating itself is 3. So we have 0. Write the number once. There are no more numbers. And we don't just stop there. The next thing we have to do is put a dot above that 3. It sort of has like a cherry on top. And that's it. That's how we write our final answer. That dot is saying 3 reoccurs or repeats itself forever and ever and ever. But it's much quicker writing it like this than doing 3 forever. Now let's have a look at B. This one's a tricky one. So let's have a look. We've got 4.7565656, and it goes on forever and ever. Now, you got to be careful with this one. Is 7 in our pattern? No, it's not. We can see that 7 appears once at the start and it stops. So what you write down first is, I'll get the reddish color. So we've got 4.7. Okay, so 4, we just always write the whole number first. Point. Because 7 isn't in my pattern, I'll just write it down. But what other numbers are in my pattern? 5, 6, 5, 6. So I will write down 5 and 6 just once. Okay, and now instead of a dot, because I have 2 numbers in my pattern, which are 5 and 6, I will put a little dash or a line above those 2 numbers. The 7 is not included because the 7 is not in the pattern. And that would be your final answer. So this is saying 4.7565656 forever and ever. And with C, we have 23 point. Now, I didn't fit it all in, but you can see the pattern. It was 1, 2, 3, 4, 5. Did I write it down right? Yeah, 5. Hang on a second. Sorry, now I've got the right numbers. So in the pattern, we've got 23 point, and let's see what's in the pattern. We've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's quite obvious what the pattern is. So write the numbers in your pattern only once. So it's 1, 2, 3, 4, 5, 6, 7. They are all the numbers in the pattern, and a line or a dash goes above them all. So that's saying 1, 2, 3, 4, 5, 6, 7 goes on forever and ever and ever. Okay? And that's it. That's how easy it is. You find the pattern, a dot for one number, or a dash for 2 or more. Now with question 22, I'll do this one here, but the other ones where you're dividing and you have remainders, there is a lesson online that you can rewatch if you get stuck. Okay? But for this one here, show how a quarter is equal to 0.25. Now, we know to put this in our calculator, it's simply saying 1 divided by 4. We know this line here, the vinculum, we know it means divide. So to get our algorithm ready when dividing, we get what we call our bridge, and we know that 1 falls down and goes under the bridge. Okay, our 1 is there and our 4 is there. Now, we also know that we have to get our decimal ready, so make our decimal visible. And then we add some zeros just to start us off. So before we even start working out anything, that is your first step. Your bridge, the top number goes under the bridge. So I say falls down and goes under the bridge. And show the decimal and add some zeros. And now this is where we just simply see we simply divide. So can 4 go into 1? No, it can't. So we have a 0. We haven't used our 1, so we carry it on to the 0 that we've added to give us 10. Can 4 go into 10? Yes, it can. 10 is larger than 4. And how many times can 4 go into 10? Well, 4, 8, 12. So that's 4 times 2 is 8. So it can fit in 2 times, and remainder 2. Now, can 4 go into 20? Yes, it can. I know 20 divided by 4 is 5, and it's even. I don't have any more remainders, so I stop. And what do we get up here? We have what our calculator would give us, 1 divided by 4, and our calculator will show us 0.25. This is what the calculator is actually doing. So we got our 0.25, and that's how we can show it mathematically. Okay, the next question that I'm doing is question 32. And we see this LCM, and we know it's not talking about LCM bars, the rice bubble bars. It's lowest common multiple. And a key word, and this is one of the hardest keywords in maths that students struggle with so much, and that is multiples. Okay? Now, a key word in there is multiply, and it involves multiplication. Now, in my class, we play snail trail, and that helps you understand what we mean by multiples. And so with the lowest common multiple of 3 and 6, your first step is to write down some multiples of each number. Now, multiples actually never end. So if I write down the multiples of 3, you always start with the number itself. because 1 times 3 is 3. And you continue 3, 6, 9, 12, 15, 18, and you can keep on going forever and ever and ever. So I've got quite a few numbers now, so I can stop there. They are the multiples of 3. Now, the next step is, what are multiples of 6? Let's try it. So I put my 6 here. Multiples of 6, so starting our snail trail, if I said 6, you would have 6, 12, 18, and so on. Now, the reason why I stopped is I can see numbers that are the same already. We have to figure out, or the question asks us, what is the lowest common multiple? So far, what common multiples do you see? I see a 6 here and a 6 here. I see a 12 here and a 12 here. I see an 18 and an 18 here. So they have quite a few common multiples already. But the lowest one is 6. Okay, so the lowest common multiple of 3 and 6 is simply 6. And that's it. And we know that 3 times 2 gives us 6. And lowest common multiples, if you remember, links with the lowest common denominator as well when it comes to fractions. That's what we're actually trying to find. Now, our next question 28 has a keyword, and that is prime numbers. And it asks us to circle the prime numbers. So we know a prime number is a number with only 2 factors, 1 and itself. For example, a prime number that I know of is 5. And because if I have something times something to give me 5, I know that, well, 1 times 5 gives me 5. Are there any other numbers to give me 5 when I multiply them? No. And they are the only factors of 5, 1 and itself. Okay? And that's why 5 is a prime number. Now, keep in mind that if there was a 1 here in this list, 1 is not a prime number. Okay? Just remember that. If there was a 1 here, 1 is not a prime number, and that's because really 1, I have to give me 1, it's 1 times 1. Are they 2 different numbers or the same number? They are the same number. So really 1 has only 1 factor, just itself. Whereas a prime number has to have 2 different factors, 1 and the number itself. We can see 1 and 5 are 2 different numbers. So 1 is not a prime number. On your test, it may ask you that, so just keep that in mind. Now, to circle the prime numbers, we'll go through this list starting with 3. Is 3 a prime number? Yes, it is, because the only thing to give me 3 is 1 times 3. There's nothing else. Is 16 a prime number? Well, no, because I know that 1 times 16 is 16, but also 4 times 4 is 16. So, and also 2 times 8. It has a lot more factors. So 16 is a composite number, which is the opposite of a prime number. A composite number is saying it has more than 2 factors. So 16 has quite a few factors. 19. Well, I know that 1 times 19 gives me 19. Is there anything else? Thinking of my timetables? No, there isn't. So 19 is a prime number. Okay? Let's see. 27. Well, I know that 9 times 3 is 27. So 27 is not a prime number. It's composite. 39. Thinking of my timetables. Well, 1 times 39 is 39. Is there anything else that gives me 39? I can't think of anything. So 39, yes, is a prime number. 49. It's quite similar to 39, but I know that 7 times 7 is 49, as well as 1 times 49. So 49 is not a prime number, it's composite. 50 is an even number. Now we know the only even number that's a prime number is number 2. 2 is the only even prime number. And that actually answers question 27. 27 says, is there an even number that's a prime number? Yes, it is. There is. The number is only 2. 2 is the only even prime number. So that's the answer for question 27. So 50 is even. So it's definitely not a prime number. 71. Can you think of something else or something else to give you 71? Maybe we can grab our calculator and have a look and see. So we grab our calculator just quickly. I can't think of a times table that goes into 71. So I might try some other numbers. 71 may be divided by 30. Will that work? No, we get a decimal. What about 71 divided by, let's say, 29? Does that work? No. So 79 is actually a prime number. Oh, sorry, 71 is actually a prime number. Okay, the only number times itself is 1 times 71, nothing else. And 100 is not a prime number because we know it's even. So for example, 50 times 2 is 100, and so on. So out of this list, we had 1, 2, 3, 4 prime numbers. Now, if you wanted to, if you have some time, if you go to Google, you can actually type in the first 1,000 primes or 1,000 prime numbers, and it will come up with a whole list of the first 1,000 primes. And I might just show you quickly. So I've just googled the first 1,000 prime numbers, and you can see that we've got 2, 3, 5, 7. There's 71. There's more on this side that come from the screen. So there's quite a few prime numbers up to 1,000, 101, 103. So there's a whole heap where these numbers only have two factors, 1 and itself. Now the next question that I'm doing is question 42. So we are almost done. And question 42 says simplify. Now we know simplify means to make something more simple. Okay, and I can see I've got 1, 2, 3, 4, 5 threes times 5. I won't fit it all on one line, but you can see how it is on your paper. Times 8 times 8 times 8. And the question says simplify by leaving your answer in index form. So remember, index numbers or index form, okay, we know index means index numbers or powers. So for example, this number here, 2 to the power of 3, this is an index form, okay? In expanded form, I would have 2 times 2 times 2. Okay, so now the question is asking us to put this in index form. So we should have something like this. And you notice that we have more than one number. There's a 3s, there's 5s, and there's 8s. So all you got to do is, your first step is, this is a shortcut way, write down the different numbers you see. And what goes in between them? Times. So 3, then I see a 5, then I see an 8. Okay, that's pretty much my answer, but now we have to put in the index numbers, the powers. How many 3s do you see in the whole thing? There's 1, 2, 3, 4, 5, so power 5. How many 5s do you see? 1, 2, so that's 2. And how many 8s do you see? There are 3. And that is your answer. So this is how we simplify numbers when we're multiplying them, the same numbers, in index form. And this is what we're going to use when doing a factor tree. So questions 48 and 49, they both ask the same thing. Draw a factor tree, in this case of 45, and express this number in prime factor form. Okay, so that's an important thing there. Express this number in prime factor form. Okay, so prime factors, we know what prime numbers are. So we're showing all the prime numbers, and it should look something like the question we did before. So keep that in mind. There's two parts to this question. A factor tree, and then our final answer, which we'll get to. So with this question here, 45, always start off with your two branches and something times something to give us 45. We can't do 45 times 1 because that's back to the start. So something else you can think of, well, I know my 5 timetables, and 5 times 9 is 45. I'm going to write my prime number first, so 5 times 9. So my tree stays a bit neater. Now 5 is a prime number. We know a prime number has only two factors, so I stop there. Each branch must stop at a prime number. But is 9 a prime number? No, it's not. Yes, it's an odd number, but I know that 3 times 3 can also give me 9. Now is 3 a prime number? Yes, it is. So guess what? Our factor tree is finished. Now what you do next is you can circle the prime numbers 5, 3, and 3 to highlight them and to make sure that your factor tree is correct. And your next step is to get these prime numbers or prime factors, like the question asks, and we know there's an invisible multiplication everywhere. So we have this 5 times a 3 times a 3. Now do a check. 5 times 3 times 3 should always give you 45. The prime numbers, the prime factors, multiply to give you the number you started off with. Let's double check. 5 times 3 is 15. And 15 times 3, yes, it is 45. So we have done the right thing. Okay, and now we have to simplify this. Like we did before, we've got 5 times, how many 3's do you see? I see 2 3's. And that would be your final answer in prime factor form. So the question is asking two things. One, a factor tree, and number two, prime factor form. Okay, so I'm always finished with this lesson. There are a few more questions that I want to do on BidMaths because a lot of students make mistakes with this. So 52 said, this is our question, 10 take away 2 multiplied by 3. So we know with BidMaths, we haven't got brackets or powers, but times comes before subtraction. So I have to do this, okay? I have to go 2 times 3 first. 2 times 3 is 6, okay? So then I'm left with, I'll put an equal sign. I'll do it over here because I haven't got room. So equals, I'm left with 10 to take away here, take away 6. And 10 take away 6 is simply 4, okay? And that's your final answer. You should have had 4. So if you went 10 take away 2 first and got an 8, and then when 8 times 3 is 24, you made a mistake. Times comes first. 53, this one's looking a bit tricky. So your first step is, let's see what operations we have. We have multiplication, we have addition, and we have division. Now we know that multiplication and division, they're equal operations, but they are more powerful than addition. So addition has to come last. So in this example, I'm going to put brackets around what I do first. I must go 2 times 3 first, and also I must go 12 divided by 6 first. Addition comes last. So 2 times 3 I know is 6. 12 divided by 6 I know is 2. So my next step is to write some working out. So what do I have left? 6. A plus is in the middle, plus the 2, and 6 plus 2 is simply 8. So that answer you should have gotten an 8. So remember, times and division come equally first or equally before addition. And the plus came last. This one down here, I can see powers, I can see brackets. So let's work with my brackets first and maybe my power as well. So in my brackets, to be very careful, we have 3 plus 2 times 6. What comes first, plus or times? Well, we know that 2 times 6 has to come first inside the brackets. So 2 times 6 is 12. And then I can go 3 plus 12. So the whole thing is 3 plus 12 is 15. So this bracket here, inside the bracket, I ended up with 15. And remember, 2 times 6 came first. So the other thing I can also do next is 2 to the power of 3. I know 2 times 2 times 2 is 8. So I'll stop there and I'll write down what I have left. So I have 8 plus 4. Times is here, so times. My number in the brackets came to 15. I'm almost done. Now be very careful. If you go 8 plus 4 to give you 12, you've made a mistake. What comes first? Check your operations. We've got addition and multiplication. I know multiplication comes first. So I must do 4 times 15 first. So I now have 8 plus 4 times 15 to give me 60. And our final answer, 8 plus 60 is 68. So you should have had 68 for that one there. Alright, the next two I'm doing, they look really complicated, but they're actually really easy. But you have to make sure you know how to use the radical sign. Okay, and we went through it just before. So this one here, we can see we've got the radical sign. In this case, it's a square root. But in here, we've got 2 squared plus 12. So your first step is, don't forget to write the radical sign, is to work out what do I have under here. What is 2 squared plus 12? I know 2 squared is saying 2 times 2, which is 4. And then I have 4 plus 12. What is 4 plus 12? Well, I know 4 plus 12 is 16. And now the square root of 16, is there a number times itself twice to give us 16? I'll put the answer up here. Yes, there is. I know 4 times 4 is 16. So the answer is 4. And that should have been your final answer. So with this one down here, let's do the same thing. We've got in our brackets the square root of 144. What is something times something to give me 144? I know 12 times 12 is 144. So the square root of 144 is 12. And also 12 squared is saying 12 times 12. Well, 12 times 12 is 144. So what I have is 12 plus, still in brackets, 144, take away, and then here I have 4 root of 16. Is there a number times itself 4 times to give you 16, the same number? Start with 2, and the answer is 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the number is 2. So 4 root of 16 is simply 2. And now I'll still work in my brackets. 12 plus 144. I have 156. And don't forget, take away 2. And finally, 156 take away 2 leaves me with 154. And that should have been your final answer. Now, the last question that I'm doing is 58, which is the last question on the practice test. Now, you notice that we have 2 sets of brackets. Now, these brackets actually look the same. Sometimes we see brackets like this. So with the outside brackets, I'm going to just change them to these ones here. Sometimes we see that. And the reason why I've done that is you can see that these are the bigger outside brackets. These are the smaller brackets in the inside. And when you have 2 sets of brackets, we know we work from inside out. So in these big brackets, I have these little brackets, and in here is 7 plus 2. 7 plus 2 is simply 9. Okay, so to show clear working out, I'm going to stop there and write down what I have left. 10 plus, I still have those big brackets that I changed. 45 divided by 9, close my brackets, times 8. So I still have brackets, so I must work inside the brackets. 45 divided by 9, I know that leaves me with 5. So I'm left with 10 plus 5 times 8. Now, our final step is, before we go 10 plus 5 is 15, check our operations. What comes first, plus or times? We know times comes first, so I must do 5 times 8 first. 5 times 8 is 40. So I have now 10 plus 40, and 10 plus 40 is just 50. And that should have been your final answer. So keep practicing for your test. If you have any questions, please come and see me. Thank you.